హలో స్టూడెంట్స్, ఈ వీడియోలో మనము టీఎస్ జెన్కో ఏఈ ఎగ్జామ్ సంబంధించి ఎలక్ట్రానిక్స్ అండ్ మెకానికల్ ఇంజనీరింగ్ వాళ్ళకు బేసిక్ ఎలక్ట్రికల్ ఇంజనీరింగ్ అనే సబ్జెక్ట్ ఉంది కదా. సో ఆ బేసిక్ ఎలక్ట్రికల్ సంబంధించి సబ్జెక్టు రివిజన్లో, సో బీడబ్ల్యూ సబ్జెక్ట్ రివిజన్లో ఇది థర్డ్ వీడియో. సో ఈ థర్డ్ వీడియోలో మనము సిరీస్ అండ్ ప్యారల్ కనెక్షన్ ఆఫ్ రెసిస్టర్స్, ఇండక్టర్స్, కెపాసిటర్స్ గురించి అండ్ బేసిక్స్ ఆఫ్ ఎలక్ట్రోమాగ్నెటిజం కాన్సెప్ట్స్ గురించి క్విక్గా రివిజన్ చేద్దాము. ఫస్ట్ రెసిస్టర్స్ అండ్ సిరీస్ అనే కాన్సెప్ట్ ఒకసారి చూద్దాము. ఇది మనకు కొన్ని క్వశ్చన్స్ సాల్వ్ చేయడానికి కూడా ఈ కాన్సెప్ట్ చాలా చాలా ఇంపార్టెంట్. సో లెట్ us say దిస్ ఈజ్ R1 and it is R2 and R1 resistor second end is connected to R2 resistor first end and both are connected with the power supply. Let us say this is a power supply V and current I started flowing, here also I and here also I. From R1 to R2 there is only one path for the current. From R1 to R2 current is not dividing, therefore R1 and R2 are connected in what connection? R1 and R2 are connected in series connection. From R1 to R2 we have only one path for the current. When there is only one path for the current, then things are connected in series. Let us see one more connection. This is R1 and let us say this is R2 and these two R1 and R2 both the resistors first ends are connected to one common point A and R1 and R2 both the resistors second ends are connected to another common point B. This type of connection is known as parallel connection. Let us say both are connected with the power supply V. Let us say current I started flowing and this current I is dividing into two parts. One part is through R1, I am calling as I1. One part through the R2, that is I2. So current through the R1 and current through the R2 is not same. So current is dividing. Current has two paths. When the current has two paths, let us say this I1 current is coming here and again this I1 is dividing into again two parts. One part is going through this path and one part is going through this path. So current is dividing. Same current is not flowing through R1 comma R2. Therefore R1 and R2 are connected in parallel. So what we can say, this is the parallel connection. In parallel connection, both the resistors first end at one common point, both the resistors second end at other common point and current is dividing. That connection is known as parallel connection. In parallel connection we clearly see current is dividing. And what about the voltage? Voltage across R1, voltage across R2 is same. In parallel connection voltage across R1, voltage across R2 is same. That value is equal to what? V. Why? See, R1 first end is connected to power supply positive terminal and R2 first end also connected to power supply positive terminal. R1 second end, R2 second, both the second ends are connected to power supply negative terminal. What is the potential difference between power supply positive terminal, negative terminal? The voltage V. Therefore potential across R1 and potential across R2, potential difference across R1 and R2 is nothing but what? V. So as R1, R2 first ends are connected to one terminal, R1 and R2 second ends are connected to other terminal. So the potential difference between these two terminals is V. So in parallel connection, voltage across R1 and voltage across R2, that is equal to same and that value is equal to what? Voltage V. In series connection, you see when current flowing through the resistor, energy of the electrons is going to be lost in the R1 in the form of a voltage drop, and let us say that I am calling as V1 and voltage drop in the R2 that I am calling as V2. V1 value depends upon R1. If resistance is more, voltage drop will be more, and resistance is less, voltage drop will be less. So from here both the resistors are different, therefore voltage drop V1 and V2 are different. This input supply voltage is going to be divided into two parts. One part is V1 and other part is nothing but what? V2. So in series connection what we can observe, current through the R1, current through the R2 is same. So current is same. In series connection current is same. Voltage may be different, voltage may be different. But if R1 and R2 both are same, resistors are same, then voltage drop is going to be same. But if R1 R2 are different, voltage may be different. In parallel connection, voltage across the elements is same, but current through the elements will be different. Current is different and voltage is nothing but what? Same. This is about series circuit and a parallel circuit. So as in series circuit voltage is different, we say series circuit as voltage divider circuit. Series circuit is known as what? Voltage divider circuit. In parallel circuit current is different, therefore parallel circuit is known as what? Current divider circuit. So let us quickly go through the series connection and parallel connection. Here you can see R1, R2, R3 are connected in series with the power supply voltage V. Voltage across R1 is V1, voltage across R2 is V2, voltage across R3 is V3. So if I apply the KVL, again I am telling how to apply the KVL. It is very important. As current is entering here, this terminal is positive, negative, and as current is entering, it what terminal current is entering, that I am assuming is positive, and this leaving terminal is negative. Here again current is entering at R3 left hand side, this is positive and this is negative. So voltage across, I am applying KVL in this manner. So first I am coming across negative terminal, therefore minus V, and I am coming across here, first positive terminal is coming, voltage across R1 is V1, so plus V1 will come. When I am coming across R2, I am coming across positive first, plus V2, and when I am coming across R3, I am coming across positive terminal first, plus V3 is equal to 0. So V is equal to V1 plus V2 plus V3. So like that, if I calculate whenever R1 and R2 R3, whenever resistors R1 and R2 R3 are connected in series, then total resistance or equivalent resistance equal to R1 plus R2 plus R3 plus and so on Rn. So let us say there are 4 resistors, each resistance value is R, connected in series, then total resistance is equal to N times R. N means number of resistors, number of equal resistors. How many resistors? 4. And what is the resistance of a resistor? 4R. So this is about series connection. Now see in parallel connection, let us see the parallel connection. So this is the parallel connection of resistors. So you see R1 first end and this R2 first end and R3 first end. All the 3 resistors first ends are connected to one common point, that is positive terminal. R1 second end, R2 second end, R3 second end, all the 3 resistors second ends are connected to other common point. This type of connection is known as what? Parallel connection. You see whenever current I1 is coming, and here current is dividing into 3 parts. So current division is happening means what connection it is? Parallel connection. You see total current I is dividing into 3 parts. So current is dividing means, so that connection is known as parallel connection. Voltage across R1, voltage across R2, voltage across R3, nothing but their first terminal, second terminal potential difference. First terminal, second terminal potential difference is what? V. So voltage across R1, voltage across R2, voltage across R3 is equal to what? V. So whenever R1 and R2 and R3 are connected in parallel, what is the total resistance we want to find? So what is the total resistance formula? 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is a formula of equal resistance, to equivalent resistance or total resistance when the resistors are connected in parallel. See, I am taking only 2 resistors now. Whenever 2 resistors R1, R2 are connected in parallel, what is the equivalent resistance or total resistance is R1 R2 divided by R1 plus R2. So very important formula. Whenever R1 and R2 are connected in parallel, total resistance formula is what? R1 R2 by R1 plus R2. Here one small formula I will discuss in the parallel connection of resistors. Let us say some 4 resistors are connected. Each resistor value is same. That value is nothing but what? R. 4 resistors each resistance value is R, they are connected in what connection? Parallel connection. Then what is the total resistance we want to calculate? You know what is the small formula? Total resistance R total or equivalent resistance is equal to R divided by N. R means that resistance value is R. N means number of same resistors, that is 4. So R divided by 4. Let us say 10 ohm resistors, each 10 ohm resistors, some 5 are connected in parallel. Then what is the equivalent resistance? N is equal to 5 here, R is equal to 10 here. So what is the formula? R divided by N. R is 10 and by 5. So what is the answer? 2. So whenever resistors are connected in parallel, total resistance value is decreasing. You see this point. Whenever resistors are connected in series, the total resistance is going to increase. So this is the whenever resistors are connected in series and resistors are connected in parallel. As already we have discussed, series circuit acts as a voltage divider circuit, parallel circuit acts as a current divider circuit. So we have one important formula, that is voltage division formula and current division formula. Let us start with the voltage division formula. See here, R1 and R2 both are connected in series across the power supply V, and this input supply V is dividing into two parts. One part is V1 and the other part is V2. Let us say I know what is the total voltage V, but I want to find V1 value, or I want to find V2 value. How to find that V1 and V2 values are? Let us say voltage across R1 V1 I want. So voltage across R1 V1 is equal to, the formula is voltage across any resistor is equal to total voltage into the resistor in which we are finding the voltage. The resistor in which we are finding the voltage divided by sum of resistors connected in series. Here V1 nothing but voltage across R1. So V1 is equal to, what is the total voltage to the circuit? That is V into resistor in which we are finding the voltage. We are finding the voltage in R1. Therefore here what will come? R1 will come. And sum of resistors connected in series. Here only two resistors are there, R1 and R2 both are connected in series. Sum I want to take, R1 plus R2. Similarly, I want to find out the voltage across R2. I want to find out the voltage across R2, that is V2 value. So V2 is equal to, first of all, total voltage. Total voltage is V into the resistor in which we are finding the voltage. In which resistor we are finding the voltage? R2. So V into R2 divided by sum of resistors connected in series. R2 and R1 both are connected in series. R2 plus R1 or R1 plus R2 both are same. This is the voltage division formula. Very, very important formula. Next we will see current division formula. Here we will see current division formula. Let us say this is R1 and this is R2. Both are connected in parallel across the power supply voltage V, and total current is I, and it is I1 and it is I2. So I know the total current, and this total current is getting divided into two parts. One part is I1 and other part is I2. I want to find out this I1 individual current. Then what is the current division formula is, current through any resistor is equal to total current into opposite branch resistance divided by sum of resistors. Here opposite branch resistance means in which branch we are finding the voltage. In parallel with that branch, what is that parallel branch total resistance? Here opposite resistance means parallel branch resistance we have to take. So example, I want to find the I1 value. So I1 is equal to, what is the formula? Total current. Sorry, this is total current. So in this case, what is the total current? I. So total current I into opposite resistance. We are finding the current through the R1. To the R1, what is the opposite parallel branch resistance? Opposite parallel branch resistance is nothing but what? R2. I into R2 divided by sum of resistors in parallel R1 and R2. So this is R1 plus R2. So total current into opposite branch resistance divided by R1 plus R2. Let us say one more case I will show you here. Here, just take like this. Here, this is R1 and this is R2, and one more resistor is there in series with R2, that is R3. And here, power supply voltage V, and total current I is getting divided into two parts. Again, I am assuming this as I1 and this as what? I2. I want to find out the I1 value. So I1 is equal to, I1 nothing but current through the, sorry, this is, I want to find out the I1 value. I1 nothing but current through the R1. So what is the formula? First total current will come. So total current into opposite parallel branch resistance divided by sum of resistances. So that is equal to, what is the total current for I1? From where I1 is coming? I1 is coming from I. So total current is I into opposite resistance. We are finding the current through the R1. To R1, what is the parallel branch resistance we want to find? To the R1, what is the parallel branch? To this R1, what is the parallel branch? Not only R2, R3 series combination is in parallel with R1. Only R2 is not parallel with R1. Only R3 is not parallel with R1. R2, R3 entire this series combination first end is connected to R1 first end. R2, R3 series combination, entire series combination is connected with R1 second end. So to the R1, what is the opposite resistance or parallel branch resistance? It is not only R2, not only R3, it is a series combination of R2 and R3. So in place of this opposite resistance, what we will get here is R2 plus R3 divided by sum of resistance in parallel. So that is R1 plus R2 plus R3. So this is the current division formula. Very, very important formula when we are solving with the circuits. Next concept, we will start with the self-inductance. So what is the meaning of self-inductance is, let us say this is the inductor. When current flows through the inductor, and if it is AC current, then it will produce AC flux. Then this AC flux links with the coil, then EMF will be induced. So here, the voltage produced in the coil, this voltage produced in the coil, due to the change in the magnetic flux surrounding the coil, due to this flux which is caused by the change in the current itself. So this voltage in the coil